Okay, once you have calculated all the original ground levels, the next step is you have to plot them. And this is how you plot these original ground levels. If you if you look at this, these levels, all of these levels are within the range of above 400 meters, 467, and so on and so on and so on. Okay, so what I have done is I have already given you a datum of 400 meters over here. What it means is that you have to plot anything above 400 meters over here. To do that, all you have to do is just go to Tools, Drafting Settings, and make sure that you have the endpoint and intersection snap on. And then click on the circle icon over here, pick up the endpoint, and radius of this will be 67.157 because we already have 400 over there. So just put over here 67.157, 67.157. Let's do it one more time. 67.157. The next level is 468.160. So just draw another circle over here with a radius of 68.160, 68.160. The next one is 468.877. So I'm going to click over here and draw 68.877. The next one is 69.169. 69.169. And then all you have to do is just join those lines, and these ones have already been drawn. This was just to show you how it is done. Then get rid of all the circles. So there is your original ground levels. Now if you see this, uh, we cannot drive on this road like this because these are not the design levels, these are the original ground levels. Okay, so what we need to do now is to create the find out the original design levels. We have to insert a curve over here, so I'm going to get rid of these lines. Okay, and just offset. Okay, so the next step is to enter the design levels. To do that, what we need to do is we go to Tools, Drafting Settings, clear everything, and just go to Nearest. Okay, so we are going to insert a vertical curve over here so that we can drive on the road safely and without any bumps. So let us now go over here, and I'm going to create a new layer, and I'm going to call this as design levels. Design levels. Okay, and I'm going to double click on this one to make it my current layer. Change the color so that it is visible on my screen. The blue one is, so now I'll be working on the design levels. So all you have to do is just click over here, go closer to this one, click over here, and then goes in the middle, and then go over here and click. As you can see, we have G1, this is G1, and this is G1, grade 1 and grade 2. And you can appreciate that this is a straight line and this is a straight line. So we have to insert a vertical curve over here. To do that, we need to figure out what is G1 and what is G2. And I'm going to switch off the OGLs because we don't need them for this exercise. So here, this is G1 and this is G2. And we have to insert a vertical curve over here. So let me show you how to calculate the G1 and G2. Okay, so if you look at this one over here, G1 will be equal to, grade 1 will be equal to rise over run. Basically what we have to do is we have to figure out what is the distance over here minus the distance over here. That will give you the total rise over a distance of this one. So let's find out how to do that. So first of all, we need to find out G1. So G1 will be, my writing is not going to be so good because this is a tablet, so I don't like writing on tablets, but anyway, I have to do it for this video. Okay, so let us go over here and find out the distance over here. So we first of all, tools, drafting settings, change it to endpoint or intersection, and now we can find out the distance from there to there, which is 92.256. So 92.256 minus the distance from there to there, and that gives you 66.634. 66 point, sorry, 66 point, hold on, 634, 66.634. Sorry about the handwriting. And so this is the rise, the difference of this height minus the difference of this height over the distance from this point to this point over here, which is 850. So it will be 850 multiplied by 100. That will give me the grade percentage. So I'll calculate that. 92.256 at 66.634. 634 and then divided by 850 and multiplied by 100. That gives me positive 3.014%, and that is my G1. Similarly, I have to figure out G2, same procedure. This will remain the same because this is common, minus we go over here and we find out the distance over here. Distance from there to there will be 75.128. And over the total distance will be 800 multiplied by 100, and that will give you the G2. So 92.256, 75.128, and, multiplied by 100, and that will give you a negative value because it is going down, negative 2.141%. So we have our G1 and G2. The second thing that the next thing that we have to find out is the length of the curve. As you know that A is, you can find out A, which is the difference in the length of the G2 minus G1, and that will give you a value of minus 5.155. Let me do it one more time just to confirm. G2 is and G1 is 3 point negative 5.155. That is the value of A. And the value, since we have to figure out the length of the curve, that is equal to K multiplied by A. The value of K can be figured out from the notes. So if we go to the notes, bear with me, I'll just get the notes and figure out the value of K for you guys. Since it's not a sag curve, it's a crest curve. So here is your K values. Here is your K value for the crest curves. In the crest curve, G1 is positive, G2 is negative. So in this case, The design velocity is 120 kilometers per hour. Therefore, the K value will be equal to 202. Okay, here is your K value and length for crest vertical curves. Therefore, we are going to use a value of 202 for a design velocity of 120 kilometers per hour. So that will give me, we'll take the absolute value of A, okay? It's always the case. 202 multiplied by the absolute value of A, and that gives me a length of 1041 meters, which is equal to almost, I'll just put it 1000 meters. Okay. So 1000 meters is the length of my vertical curve. So this is what I'm going to do. I'll go back to my drawing here, and since this is my point of vertical intersection, VIP, this is called the VIP, I have to figure out the BVC, beginning of the vertical curve, and EVC, end of the vertical curve. So I'm just going to elongate a little bit. And then offset it. Since the total length of the curve is 1000 meters, so I'll go 500 meters this way and 500 meters this way. So I'll do offset 500 towards the right and towards the left. So this is where my vertical curve is going to be, because I will not be driving over here right there. There is kink. So we have to now insert a vertical curve over here. This is my BVC, this is my EVC, and this is the PVI, point of vertical intersection. The chainage at PVC is 2350 and the chainage at EVC is 3350. Okay. So we have G1, we have G2, we have the length of the curve. Okay. So now we have to figure out what are the elevations of the curves over here on these points over here. So therefore, we'll be able to drive smoothly on this one. Okay, so we have to figure out those curves. So we have all the information. Let me see. The chainage over here is 2350 and the chainage over here is 3350. As we can figure out that the total length is 1000 meters. So I'll just put this information over here. Chainage at BVC is 2350 and chainage at EVC is 3350 and chainage at PVI is 2850. We need all this information for we'll enter all this information into the Excel sheet and figure out the elevations of the curve at different chainages. Okay, so let's do that. Let us now work on our Excel file, which is you can download that Excel file from the BVL. I I told you in the beginning also. So we go back to our project files and we pick up the Excel sheet to calculate the elevations. Here we go. So as you can see, the values that have to be entered are all in red color. So let me see G1, G2. Okay, so we go over here. And G1 is 3.014. Three point 014. So I'll put over here because it's going up, therefore I'm going to put it. So positive value 3.014. G2 will be minus 2.141, negative 2.141. Okay. Now the length of the curve, we know that we'll enter the C. If you look at this one, it has already calculated the A value for you guys because G2 and G1 are given. The chainages from the BVC up to the end of the curve, and we know that it starts with a chainage of 2350 to 28 2350 to 3350. So we go over here, we say 2350, and since it is every 50 meters will be 2400. So we'll just highlight these two and go up to 3350. Up to here 3350, and we'll drag this value up to here. The elevation of the curve is 1000, the length of the curve is 1000. So we drag this value down up to here. Okay, and this also we have to drag it down, this one too, this one, and this is the only thing left that we need to figure out: tangent elevation. How much is the elevation at the beginning of the vertical curve? Okay, so this is how we do it. We go to this point and we at 2350. What is the elevation over here is 477.723, 477.723, no, not 477.723. I'm sorry. Just check the distance because these are the original ground values and not the design levels. So let me see. I'm going to say distance DIST, enter, from here to here, and that is 77.185. 77.185. So I'll just put that value over here, 477.185. So why 477? Because the original values, we have to add 400 over there. This is 477.185 is the beginning of the vertical curve. So my curve is going to start over here at this point, and then it goes all the way over here. Okay, if our calculations are all fine, we have to figure out this value. We not figure out this value. If this the distance from here to here matches the number in my Excel sheet for 3350, which is 481.550, then our calculations are fine. But if that number does not match 481.550, then we'll be in trouble. We have to redo everything one more time. Okay, so let's see if in my AutoCAD file I get this number 481.550. Okay, keep your fingers crossed. Let's see. So I say DIST and 81.551. So we are in very good shape. Let me do it one more time. Yeah, good. 81.51. 1 millimeters, no problem. So 481.550 was the value that we had over here in my Excel sheet. See, 481.551. So we are fine. Now, these are all the elevations at all the chainage points over here. These are all the elevations, okay, road elevations, and we will look at the PVI. The PVI is over here. Where is the PVI? Let me show you where the PVI is. The PVI is at 2850. Okay, 2850. If we look at the elevation at 2850, that will be right there, 2850. This is 485.811, 485.811. So I will plot a circle of radius 85.811 on my AutoCAD, 85.811. So I'll just go over here, 85.811. Let me see, I'm right. Yeah. So now what I can do is I can trim this part over of the curve from here to here because I'm going to insert the curve. So trim, right? So I'm going to get the spline. Where is the spline? Right there. Click, 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 and enter. So I'll change the color of this to red so that you can see that this is the curve we are looking at. So there, that is my curve right there. Now to get all the, so these, all you have to do is now put the formation levels over here. From this point to this point, all you have to do is find out, we have this value from the beginning, okay? So we can do it one more time. I'll just put over here dist st distance. So check it up. This value 66.634 goes over here. 466.634. 466.634. 466.63634. Okay. Similarly, you find out the distance from there to there, put that number over here. The distance from there to there, put that number over here. Just add additional 4 over there because this 4 has to be added. So up to this point, you do the same thing. What about the red zone over here, the curve itself? These values are going to come from your Excel sheet. These values from 2350 up to the end, to 3350. So all of these values, you can copy and paste them over here. I can show it to you how to do it. Just see this one over here, just say uh, copy. So these will be copied over here, and you go back to your AutoCAD file over here, and then just paste them somewhere. Just type over here text text. Okay, here is your start point. Text height is 15. Enter. Rotation angle is 0, and then just Control V. Okay, so you have all those values. Put them over here. Just move them one by one over here. So this one goes over here. This one goes over there. Here like that. Let me show you. Move. And then you have to scale them down a little bit, but you get the idea, right? You just put them over here. Okay, and this is 2350, so I'm going to scale it down a little bit. 0.5 maybe, I don't know. Yeah, so that way you will just put all these values one by one over here. So this is the last one. I'll just move this one, move all of them will go over here, and the last one will go at 3350. And these values similar to this value. So just find out the distance over here, over here, over here, over here, over here, and put them over here. So that will populate this portion, this formation level portion. Okay, just like this. I'll just uh, show you the from the previous calculations. So you will get now. Now comes the part where you have to cut or fill. So all you have to do is when you have all of these values written down over there, this one minus this one will give you this one. This one minus this one will give you this one. This one minus this one will give you all the cut or fill values. So hopefully you should be able to do this now. If you have any questions, you can always refer back to me, send me an email, and I'll give you all the details that I can. Thank you.